So the last method that we have is for solving quadratics is using the quadratic formula. So when in doubt, you can always do this. So the quadratic formula is just something you have to memorize, and we'll talk about it in a second. So it's easier just to write down all these steps. So to actually use the quadratic formula, you need to make sure to rewrite everything in the form of ax squared plus bx plus c equals 0. So moving all the terms to one side and obtaining 0 on the other. Then you use the quadratic formula. So the quadratic formula is x equals, so this is super important, everyone forgets what the whole formula is equal to. It's equal to x. X is the thing that we are squaring, right? It's our variable in this case. We're squaring it, it's regular, it's not there at all. That's the variable for the polynomial. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. And this is just something you have to memorize. So there is a couple of silly songs you can remember. One goes by Pop Goes the Weasel, and I will sing it for you now, so we can all have a great laugh, but hopefully you'll be able to remember it because of this. So like I said, it goes with the phrase of Pop Goes the Weasel. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so if you want to go ahead, you can just rewind that, listen to it on repeat. It'll be great. But maybe that can be an easy way for you to remember what the quadratic formula is. So step 2, use the quadratic formula. Step 3, make sure you simplify. Simplify the radicals. Simplify whatever we need to simplify. And then, of course, step 4, as always, check the equations. All right, so this is mostly it. We're going to do 4 examples, and then we're going to talk about something kind of cool with the quadratic formula. Well, I think it's cool. All right, so it is already in our form. Step 1 is completed. So step 2, we need to use our quadratic formula. So in this case, we see that a is 8, b is 2, and c is negative 1, right? A is in front of the x squared, b is in front of the x, c is all by its lonesome. So use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to get you to sing it by the end of this. Haha. All right, so that's negative 2 plus or minus the square root of 2 squared minus 4 times 8 times negative 1 divided by 2 times 8. So I just plugged all these numbers where they're supposed to go. And then step 3, simplify. So negative 2 plus or minus the square root. So 2 squared is 4. Negative 4 times 8 is negative 32 times negative 1 is positive 32. So plus 32 divided by 2 times 8, which is 16. Yeah. So 4 plus 32 is the square root of 36. So 36, hopefully we can see that that's 6 times 6. So that's already a pair that comes out. So x is negative 2 plus or minus 6 divided by 16. So we can actually simplify this, right? This gives us 2 separate equations. We have x equals negative 2 plus 6 divided by 16. And we have x equals negative 2 minus 6 divided by 16. 2 different equations. So in the first equation, right, we get negative 2 plus 6 is positive 4 divided by 16. And then we can simplify that by dividing both sides by 4, right? So 4 divided by 4 is 1. 16 divided by 4 is 4. So we get 1/4. X is 1/4. In this case, right, negative 2 minus 6 is going to be negative 8 divided by 16. We can divide both sides by 8, top and the bottom. So we end up with negative 1/2. So our solution set is 1/4, negative 1/2. And that's it. We're done. All right, number 2. Step 1, get everything to one side. So 2x squared minus 4x minus 1, to get them on the other side, equals 0. Step 2, quadratic formula. A is 2, B is negative 4, C is negative 1. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we plug it in, x equals negative 4 plus or minus the square root of negative 4 squared minus 4 times 2 times negative 1 over 2 times 2. So if we simplify, negative 4 is positive 4. Negative 4 squared is 16. So negative 4 times 2 is negative 8. Negative 8 times negative 1 is positive 8. And then 2 times 2 is 4. All right. 16 times 8 is 24. So can we simplify square root of 24? So square root of 24, that's going to be 4 and 6, 2 and 2, 2 and 3. So 1, 2 can come out, and we're left with the 2 times 3, right? So a 2 comes out, and we're left with 2 times 3, which is 6. So we see that this simplifies down to 4 plus or minus 2 square root of 6 over 4. And since we can't combine any of these with the square roots, we can actually leave it like it is. We can just simplify, right? So a way to simplify is divide everything by the 4. So if you want to, you can kind of see, you have to make sure to divide everything. You can't just say, so a way to not do it, it would be 4 divided by 4, which is 1 plus or minus 2 square root of 6. That is not correct. That does not work. Here's a perfect example, right? If you have 4 plus 1 over 4, right? That does not equal 1 plus 1, which is 2, right? Because 4 plus 1 is 5. 5/4, right? 5/4 is not the same as 2. So, just because you have something like that, it does not work because you have a plus and minus sign here. So essentially what happens is you can separate, this is a little easier to help you see it, you can separate those fractions. So 4 over 4 plus or minus 2 square root of 3, or sorry, square root of 6 over 4. And now we can simplify, right? 4 divided by 4 is 1, plus or minus 2 divided by 4, right? We can do 2 divided by 2 is 1, 4 divided by 2 is 2, so square root of 6 over 2. So that's perfectly okay to write as well. So solution set, 1 plus or minus square root of 6 over 2. The other way to have done, so if you understood that and you don't want to understand anything else, feel free to fast forward a little bit into this video. But the other way to have done this would have been, if you notice, in common with all three of them, right, the greatest common factor that we could divide each of these by is 2. So 4 divided by 2 is 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So this also can equal, right, 2 plus or minus the square root of 6 over 2. Which, if you notice, if we actually combine these, right, it's 2 over 2 plus square root of 6 over 2. So combining them, we would get 2 plus or minus square root of 6 over 2. Same answer. All right. Example 3. So step 1, get everything onto one side, writing it in standard form. So we get 3x squared plus 4x plus 2 equals 0. So A is 3, B is 4, C is 2. Quadratic formula time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we see we get negative 4 plus or minus the square root, 4 squared minus 4 times 3 times 2 over 2 times 3. So let's simplify. Negative 4 plus or minus the square root. 4 times 4 is 16. 4 times 3, and negative 4 times 3 is negative 12. Negative 12 times 2 is negative 24. So minus 24 over 2 times 3, which is 6. So negative 4 plus or minus the square root of negative 8 over 6. Oh, wait a minute. We have a negative sign inside a square root. That's bad, right? So that means that we have no real numbers, no real solutions. So our solution set, open bracket, close bracket, or 0 with the line through it. And we're done. Yeah, this one doesn't have any solutions. Last one. All right, so step 1, get everything off to the one side. So we get negative 16x squared plus 8x minus 1 is 0. We can absolutely continue this way, but it might be better just to make sure the front number is positive, right? So we can just multiply everything by negative 1. So just flip the signs of everything. Might just make things look a little easier and nicer. All right, so A is 16, B is negative 8, C is 1. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative 8 plus or minus the square root of negative 8 squared minus 4 times 16 times 1 over 2 times 16. So negative 8 is positive 8. 8 squared is 64 minus 4 times 16. So 16, 4. 4 times 16 is 24. 4 times 4 is 4. 4 times 1 is 4 plus 2 is 6. So 64 over 2 times 16, which is 32. So we get 8 plus or minus the square root of 0 over 32. Well, square root of 0 is just 0. So that just simplifies down to 8 over 32. Which, if you divide both by 8, right? 8 divided by 8 is 1. 32 divided by 8 is 4. We just get 1/4. So this time we only get one solution. The solution set is 1/4. Now that we've gone through 4 different examples, let's notice something, right? For example number, let's just go through the very top. Number 1, how many solutions did we have for number 1? We had 2 solutions. For number 2, how many solutions did we have? Again, we had 2 solutions, right? We had a positive, 1 plus square root of 6 over 2, 1 minus square root of 6 over 2. So 2 solutions. What about number 3? How many solutions did we have? None. We had no solutions. For number 4, how many solutions did we have? We had 1 solution. So for all of these equations, for every single time, anytime you have a quadratic, no matter what method you have the potential of getting 0, 1, or 2 solutions. And we can use something with the quadratic formula to determine when we have it. So maybe let's start with when do we have 0 examples? Let's go to example number 3. How did we know that we ended up with 0 examples? Well, it's because what was inside the equation was negative, right? Inside this square root, we had it, this didn't work, so we ended up with no solutions. What about when we had 1 solution? Well, inside the equation, we had 0. And so that just canceled things out. So then how did you know you had 2 equations? Inside the radical, you have an actual number, right? A positive number. So it seems like, depending on what this is, b squared minus 4ac, that will determine how many solutions we have. And that thing is called the discriminant. So the discriminant is just that inside part, b squared minus 4ac. And the discriminant, obviously, like we just said, will tell you the number of real solutions. So when the inside of the radical is positive, greater than 0, right? This is going to be like example number 2 and 3, right? Inside the radical, we had 24, or we had, for number 1, 36, right? So we end up with how many solutions? 2. So if it's positive, we end up with 2 solutions. 2 real solutions. Yeah, remember, we're only dealing with the real numbers. So for those of you who know about complex numbers, we're not dealing with that in this class. And it's not just real, it's unequal. Some people might say unequal real solutions. If it's equal to 0, this will be like example number 4, right? The inside equaled 0 in the radical, in the square root, right? So we ended up with 1 solution. So 1 repeated real solution. And the reason why it's repeated is just real quick, right? You notice that it's 1/4, right? So if you notice, this can actually be factored into 4x minus 1 squared, right? And so the reason why is because it's repeated, right? We have 4x minus 1 times 4x minus 1, right? So that's why it says repeated. And then lastly, if it's negative, right, you can't take a square root of a negative, so we have 0 real solutions. All right, last example, and then we are calling it a day for this lesson. So for number 5, compute the discriminant and then determine the number of, that should say of, real zeros. So remember, the discriminant is the inside the radical part. So b squared minus 4ac. So what's inside the radical? So negative 6 squared minus 4 times 9 times 1. Negative 6 squared is 36. 4 times 9 is 36 times 1 is 36. So we get 0. So since it equal to 0, right, when you take the square root of 0, you're going to end up with 1 real solution. All right, let's do this one. B squared minus 4ac. B squared is negative 8 squared minus 4 times 3 times 7. So negative 8 squared is 64. 4 times 3 is 12. 12 times 7, 14, 84. So when you subtract that, you get negative 20. That's negative, right? Less than 0. So you can't take a square root of it, right? So this is going to be no real solutions. Part C. So b squared minus 4ac. We get 4 squared minus 4 times 3 times negative 5. 4 squared is 16. 4 times 3 is 12, right? 12 times 5, get 0, carry the 1, 60. So 2 negatives makes a positive, so this is plus 60, which is 76. This is positive, so we end up with 2 real solutions, unequal solutions. All right, and that's it. So the only thing I want to talk about now is we have talked about 4 different ways of doing solving quadratics, right? We have talked about we can do it by factoring. We can do it using the square root property. We can do it by completing the square. And we can do it by the quadratic formula. So if you notice, I have provided this guide to solving quadratic equations. So how do you know when to use what? What would be the best way, the most effective way of doing it, just to make everything easier on you? Here it is, right? So take a look at this. If you have any questions, let me know. I would love to answer any. But if, like I said, easiest way, if you know all of these methods, right? These are the more methods that you do know and you do feel comfortable with, the more tools you have in your toolbox, right? I mean, essentially, you can always use the quadratic formula if you want. You could always use completing the square if you want. Those always work. But it's not going to be the easiest way all the time, right? So, like I said, having more of these in your back pocket, right, will give you the ability to do things a little easier in the future. So hope you understand this. If not, like always, email me or text me. You have a great day.